Good morning, children. So, in the process of metallurgy, we have learnt about ore dressing methods and extraction methods also. And extraction methods, we have dealt with three types of extraction methods. Okay, one for the metals which are on the top of the reactivity series. Okay, that is electrolytic extraction. Okay, electrolytic method, electrolysis. Okay, and the metals which are in the middle of the reactivity series, for them we have discussed calcination, roasting and smelting methods. Okay, and also for the metals which are at the bottom of the reactivity series, we have learnt the formation of complex substances. Okay, hydrometallurgy, leaching and hydrometallurgy. These methods we have learnt in previous videos. Okay, so in today's video we are going to learn about the refining methods, the third principle of principles of metallurgy. The third principle is what? Refining methods. First principle is about ore dressing. Second principle is about extraction of crude metal from its ore. Okay, and third principle is what? Whatever the metal that is being extracted, okay, either through calcination or through roasting or through smelting, whatever the methods whichever we have learnt, okay, that metal still consists of what? Some dissolved impurities. Okay, so that dissolved impurities we have to purify them. So third principle involved in the process of metallurgy is what? Purification of metals. Okay, so what are the different purification methods? Okay, that we are going to learn in this video. Okay, so in today's video, methods for purification of metals. Methods for purification of metals. Okay, now methods for purification of metals. Okay, so we have mainly 4 methods are there which are to be discussed. This is a very small topic, but you will be getting 2 marks questions in this video. Okay, so I would like you all to please go through the textbook, go through the video, keep watching my videos and please keep comments. Okay, so after finishing the chapter of metallurgy, I request all of you to please give comments to me, whichever the chapter which I have to start next. Okay, that you please give suggestions so that I will follow accordingly, right? Fine. Okay, so what are the purification methods for metals? We have mainly 4 methods are there, 4 types depending on the nature of the metals. Okay, depending on the melting and boiling point of metals, we have 4 methods are there for purification process or refining methods. These all are what? Refining methods. Okay, so what are the 4 methods? So first one is distillation. Okay, and the second one is liquation. And the third one is poling. And the fourth one is electrolytic refining. Fourth one is what? Electrolytic refining. So we have mainly 4 methods are there for purification of metals. Okay, first one is distillation, then liquation, then poling, and then we have last method is what? Electrolytic refining. So in this video, we are going to discuss about these 4 methods. A small short notes you have to prepare. Okay, please make notes every time I say that. Please keep writing notes. Okay, it will be very much useful to you to improve your vocabulary as well as your memory power. Okay, so please keep writing notes. Okay, make a copy of whatever is being written by your teachers. Okay, even in the YouTube you are following, or if you follow your normal physical classroom, please keep maintaining a notes. Okay, right. Distillation. So what is distillation? Okay, all of you have learnt this in your lower classes. Okay, see here the molten metal is subjected to different temperature zones. Okay, distillation is a method of purification of metals, okay, which has soluble impurities. Okay, ore dressing methods are what? The impurities which are on the surface we can remove. Whereas here for distillation, the impurities which are dissolved inside the metal, okay, that we have to remove now, right? So distillation is the process which is applicable for what? Distillation is nothing but a heating process only. Okay, heating of so and so mixture. Okay, separating the components of a mixture. Okay, by subjecting the mixture to different temperature zones. Okay, so at one particular temperature, one substance reaches to its boiling point, and at once it reaches to that boiling points, that particular substance get separated out from that components of that mixture. So what is distillation generally? Distillation is the process of separating the components of a mixture. The process of separating the components of a mixture. The process of separating the components of a mixture by subjecting the mixture to different temperature zones. Okay, by heating the mixture, okay, at different temperatures, by heating the mixture at different temperatures below their boiling points. Okay, at different temperatures. Okay, so at one temperature, one substance, one component reaches to its boiling point. Okay, so depending on the boiling point of that substance, that component can be separated from that mixture. Okay, so distillation method is the process of separating what? Impurities and ore particles only. Okay, here what we are separating? We are separating impurities and ore particles, right? So that process you call it as distillation. Here we have to remember one important thing. Here ore particles are having low boiling point. Ore particles are having low boiling points, and impurities are having, okay, ore particles are having low boiling points. Please remember, this is the point where you will be getting questions. Okay, during distillation, whether boiling points is low for ore particles or for impurities, that question they'll ask. You'll be getting only 1 mark question in this topic. Okay, so here ore particles are having low boiling points, and gangue particles are having, better I say instead of gangue, I say impurities. Impurities are having, here impurities means what? Dissolved impurities. Impurities are having high boiling points. Impurities are having high boiling points. Okay, so this point you have to remember. Most of the children will make mistake here only. Okay, they'll write ore particles will have high boiling points and impurities have low boiling points. No. Ore particles which are having low boiling points, okay, than the impurities. Ore particles are having low boiling point than impurities. So that what happens when you are subjecting that mixture to different temperature zones, okay, the ore particles reaches to their boiling points will comes out in the form of vapors. Okay, and that process you call it as what? Distillation. Okay, so which type of metals will undergo the process of distillation? That also a very important question you will be getting. Okay, so here this is very important point you will get. Metals like zinc, cadmium and mercury. Okay, zinc, cadmium, CD means what? Cadmium, and mercury, Hg. Okay, so these are having what? Low boiling points, and they are to be purified by the process called what? Distillation. Okay, metals like zinc, cadmium and mercury are to be purified by which method? Means you should write distillation method. Okay, of course you have different types of distillations are there. Simple distillation, fractional distillation, destructive distillation. Okay, you have lot many types are there. Okay, that you will be learning in separating the components of a mixture. There you have difference in boiling points should be less than 25 degrees for fractional distillation and greater than 25 degrees for simple distillation. Like that you have different methods are there for distillation. Here we are not going to discuss all those things. Which type of metals will undergo distillation? One more question. Zinc, cadmium and mercury. Ore particles are having low boiling points or high boiling points? Ore particles are having low boiling points and impurities are having high boiling points. These points if you write, it's highly enough for class 10. Okay, so this is all about distillation process, right? Please make a note. I'm going to rub the board. Okay, so please. And number 2, method number 2. What is the second method? Second method is what? Liquation. Second method is liquation. So if you understand the points of distillation, you yourself can write the points for liquation also. Just what you will do is, instead of writing low boiling points, here you will write low melting points. Okay, so liquation is a process in which separating the components of a mixture depending on what? Melting points of ore particles and impurities. Okay, melting points, low melting points ore should have, and impurities should have high melting points. Okay, metals in which ore particles having low melting points, and impurities having high melting points. Impurities are having high melting points and metals are having low melting point. Such kind of ore particles. Okay, such kind of ore particles are subjected to what? Such kind of ore particles are subjected to liquation. Okay, so let us learn about this. Okay. Right, impurities having high melting points are subjected to what? Are subjected to liquation process. Liquation is also kind of heating only. Okay, below its melting point. It depends on what? Liquation process. You are terming it as liquation if you are considering the melting points of metals with the low melting points. Okay, now metals with low melting points, and impurities should have high melting points. Okay, metals should have low melting points and impurities should have high melting points. Please remember, impurities should have high melting points and actual metal should have low melting point. Then you are calling that process of separation, that process you are calling it with name liquation, right? So this is very important. So here which kind of metals are subjected to liquation? Okay, tin and lead. Sn means what? Stannum, tin and lead are separated from their impurities using liquation. Separated from their impurities. Okay. Tin and lead. What kind of impurities will be there? You will have antimony impurities. Stibbium you all know. Impurities of sulfur, antimony. Okay. Such kind of impurities. Even gold. Gold also may be treated as impurity only here. Why? Because here your aim is to extract a tin. Tin from an ore. Cassiterite or lead from an ore. Galena. Whatever it may be. Okay. So it consists of other impurities also. Dissolved impurities. That dissolved impurities should have high melting points than the melting points of these actual metals which are to be extracted or which are to be used. Okay. So tin, lead are having low melting points. Okay. They melt very quickly. They melt very quickly than the impurities. Okay. Are separated from their impurities. Okay. Using liquation method. Okay. Liquation. Liquation is totally depending on what? Melting points. Please remember that point. Okay. Using liquation method. Using liquation method. Okay. Very, very important. Tin and lead. Previously in distillation what I told? Zinc, cadmium and mercury. They are having low boiling points. Okay. They have low boiling points. These metals are having low melting points. Okay. So this is liquation. And now moving on to the third one. Third one is what? Polling. Very, very important question. You'll be getting 2 marks question. Polling. Okay. So what is polling? Polling is the process in which the molten metal is stirred with logs of green wood poles. Okay, now the molten metal, please remember these words. This terminology is very much important. Okay, I told you already, you must learn the topics with a very good terminology. You have to write definitions with science terms. Okay, so please remember. So polling is the process. Refining process. Please remember, refining process. Polling is the process in which molten metal is stirred with molten metal is stirred with what? Logs of green wood poles. Is stirred with logs of green wood poles. Logs of green wood poles. Means what? Green wood. Okay, bark of a tree. Okay, bark of a tree. Green bark, not the dried one. Okay, green bark of a tree consists of certain hydrocarbons will be there. So when you are subjecting metals to a process called polling, okay, the molten metal which is in liquid state is to be stirred. Stirred means, you know, continuously mixed. Okay, stirred with what? Stirred with logs of green wood poles. Okay, bark of a tree you'll take. Bark of a tree. Okay, logs of green wood poles they'll take. Branches they'll take. And they are going to stir the metal. Continuously stirring. Okay, they are going to stir the metal with logs of green wood poles. Okay, so what they will do? If you stir it, what is the use? Okay, here one thing please remember. Here blister copper is an impure form of metal, copper metal. Blister copper is purified by this method. Okay, please remember, very, very important point. Blister copper is purified by this method. Blister copper is purified by this method. Okay, please remember this point. What is blister copper? A copper which is having small bubbles, blisters. If our skin is burnt, how it looks like? Blisters will form. Okay, so a blister copper is a kind of impure copper. Okay, it consists of copper oxide only has impurity. Please remember this point. Why this molten metal is stirred with logs of greenwood poles? You will get question like that. They may not ask the definition, or they may ask. We can't say. Okay, here the question you will get like, why in case of poling, why the molten metal is stirred with logs of greenwood poles? Why it is stirred? Means to prevent oxidation. This is very important question. So many times they are being asked, and most of the children will not write answer for this. Very important question. One single line is the answer. What is it? Why the molten metal is stirred with logs of greenwood poles? Okay, why it is stirred? Because to prevent oxidation. See, if you are stirring continuously with logs of greenwood poles, that greenwood poles will release certain gases into the molten metal. That gases will avoid that molten metal to react with atmospheric oxygen. Okay now? So what happens? They prevent oxidation. Even if you are stirring continuously, what this copper will do? Copper reacts with atmospheric oxygen. Okay, when it is in molten state, copper reacts with atmospheric oxygen and turns to copper oxide. Then what is the use of doing all these things? We want only copper. We don't want copper oxide. But as the process is going on itself, okay, it reacts with atmospheric oxygen and immediately keeps converting into copper oxide, which we don't want. That means it is undergoing oxidation. Now our aim is to prevent oxidation. So to prevent oxidation, okay, the blister copper is stirred with what? Logs of greenwood poles. Please remember the point, single line, to prevent oxidation. Okay, please note that point. Why in case of poling, okay, molten metal is stirred with logs of greenwood poles. Why? Okay, to prevent, very important point, to prevent oxidation, to prevent oxidation of copper, it is stirred with what? It is stirred with logs of greenwood poles. Logs of greenwood poles. This point very important, 2 marks question. Most of the children will not write. So please make a note. Okay, to prevent oxidation. To prevent oxidation, it is to be stirred with logs of greenwood poles. Right? And next, which metal is purified by this method? Blister copper. Please remember. Right? And next, moving on to the last one. That is electrolytic refining. Electrolytic refining. Electrolysis. Again, we have learnt all this. Fourth method is what? Electrolytic refining. So electrolytic refining means what? Again, the process of electrolysis. Here also, okay, crisply we have to learn some important points. If you just learn and write that important points, that's highly enough. You will be getting 4 marks for this. Okay, easily you can get marks. Right? So electrolytic refining, here we'll learn about the electrolytic refining of copper sulphate. Okay, electrolytic refining of copper sulphate. It is being given in your textbook. CuSO4, aqueous. Again, you have to remember one important point, aqueous or molten. What you have to take? Okay, aqueous or molten. Generally, in ore dressing methods, we have taken molten. Here you can take aqueous, aqueous copper sulphate. Okay, as what? Electrolyte. Electrolysis means you require what? One electrolyte you require. One electrolyte. Here the electrolyte is copper sulphate. Okay, and you require cathode and anode metal plates. Okay, here cathode you take as pure copper metal, pure copper rod. pure copper rod you will take as cathode. Okay, the negative terminal, you all know. And anode you will take impure copper rod. Please remember, anode you will take impure copper rod. Pure copper rod you will take as cathode, and anode you will take impure copper rod. Okay, when electricity is made to pass through it, then what happens? Here, please remember very important points. I'll draw the diagram here. Can you able to see? I'll draw it here. Okay, you all have learnt already electrolytic tank. In that, let us take this as anode or cathode or anode depending on the terminals. Okay, two metal plates, one pure copper rod and another is impure copper rod. Okay, so the one which is connected to the positive terminal, so this will be what? Anode. Anode, what you should take? Pure copper rod, pure Cu rod, and this is connected to the negative terminal, impure. Anode impure, anode impure, cathode pure Cu rod, pure copper rod. Okay, anode impure, please remember, anode impure, cathode pure. So what will happen here? Okay, so when electricity is made to pass through it, what happens? You all know, copper sulphate starts decomposing. Okay, CuSO4 decomposes into Cu2 plus and SO4 2 minus ions will come. Now these Cu2 plus ions, what they start doing? They start to migrate towards cathode. Okay, so what happens here? Please understand the point carefully. Here, impure rod consists of so many other impurities other than copper. Okay, so when electricity is made to pass through it, what happens is copper melts from anode. Copper melts from anode so that all the copper ions start migrating towards cathode. Okay, and they get deposited on cathode. Okay, they get deposited like this. They get deposited on cathode like this. Okay, Cu start migrating. Cu start melting from anode and migrate towards cathode, and they start depositing on cathode. Okay, so here oxidation happens. In anode, you all know, in anode oxidation will happen, in cathode reduction will happen. So when this impure rod is getting oxidized, it still loses its shine. Okay, because copper is going away. So if copper is going away, what happens? The size of this anode keeps decreasing. Okay, please remember that point, important point. Size of anode decreases. Because who is going away from anode? Please remember this point, very important. Size of anode decreases. Okay, and as copper ions are going and getting deposited on cathode, size of cathode keeps increasing. Okay, size of cathode increases. Size of cathode increases. Okay, copper keeps melting and going near cathode. So, and all the impurities will left behind. Okay, impurities are left behind as anode mud. Impurities are left as anode mud. Please remember this point. Impurities are left as anode mud. Okay, so this is what you call it as what? Electrolytic refining. You will take copper sulphate solution. Copper ions gets started coming out from copper sulphate. Okay, they start migrating towards cathode. Size of cathode keeps increasing, and cathode keeps it increases its shine also. It will be more shiny also. Whereas here, in case of anode, oxidation happens. If oxidation happens, what happens? The shine of anode decreases, as well as size also decreases. These 2 points compulsorily you must write. Okay, size of anode decreases, all the copper melts from anode and start getting deposited on cathode. This is what is going to happen, right? So this is all about what? Purification methods in the process of metallurgy. Okay, so these 4 methods are very, very important. I expect all of you, I hope you understood. Please keep repeating the video if you wanted to have more clarification, right? So 4 purification methods are there in your textbook, and this is all about purification methods or refining methods. Okay, so happy learning. All of you, please keep learning. Have a strong determination to get better marks in the exam. Okay, and please subscribe to my channel. Okay, and please keep comments and suggestions. What is the next chapter which you people want? Okay, so that I'll start with that chapter, right? Thanks for watching once again, and happy learning. Your hard work is your superpower. Bye.